Alright, so here we go. One of the things that you should have done before you got started with this quiz is you should have probably created the cheat sheet someplace. So the things that I said that you guys needed to know are...
Are we filling out the blank sheet with the right answers?
Yep, the blank sheet's there for you guys if you want to fill out the right answers. I wasn't going to have you try to write over the wrong ones, but here we go. I told you two special right triangles, a 30, 60, 90. Ratios are 1, 2, square root of 3. A 45, 45, 90. 1, 1, square root of 2. All right, then we have our unit circle. The important parts are going to be the coordinates of the points, 1, 0, 0, 1, negative 1, 0, 0, negative 1. The fact that this is quadrant 1, 2, quadrant 3, and quadrant 4 in terms of location. You need to know in terms of the trig functions, AS, T, and C, what trig functions are positive in the quadrants, okay? Then you needed to know with the triangles, so Katoa. You also needed to know with the unit circle that every single point on this circle, every point deals with the cosine as the x coordinate of the angle and the sine as the y coordinate of the angle. I also said that one of the trig functions that you might want to know the identity to was sine. That might help you. I'm sorry, tangent. That might help you with some of the questions. Am I missing anything? I think that's it. Okay, so those are the things that you should have written down prior to even taking the quiz. As soon as the quiz is in front of you, because you know you're not going to be allowed to use a calculator, and you and we're going to have to refer to these. So first questions, question 1, 2, and 3. Question number 1 said simply change degrees to radians and radians to degrees. So I start off with 5 pi over 8 radians. And since I'm giving you radians, I want you to change that to degrees. So we know to multiply that by 180 over pi. All right, we just got to be careful with our cancellations. All right, the pi's go away. Everybody was good with that. But just make it easy. 2 goes into 8. 2 goes into 180, 90 times. 2 goes into 4 twice. 2 goes into 90, 45 times. Okay, so now we're down to 5 times 45. And if you do 5 times 45, that's 225. And then that's going to be divided by 2. Sorry that that didn't come out to be nice. But half of 200 is 100, and half of 25 is just 12.5. And that was the final answer, to 1. Number 2, 310 degrees. Since I was giving you degrees, I wanted you to go to radian measure, so pi over 180 is what we multiply by. First of all, we can take care of the tens, each divisible by 10. Is there any number that goes into 31 and into 18? Nope, so that's my answer. Just write it. 31 pi over 18, and we're done. Number 3, 11 pi over 18. Again, it's we're going to multiply this, by 180 over pi. Pi's will cancel. And this should have been pretty easy. 18 is going to go into 180 how many times? 10 times. So we just get 110 degrees. Questions on the first 3? Okay. 4a and 4b deal with the complement and supplement of angles. Now, I said to you when we were doing the homework assignment, whatever form the question is in, that's the form I want the answer. So pi over 9 is in radian or degree? It's in radian. So I want my answer to be in radian. If it's in degree, then you have to put it back in degree. So your choice here could have been changing it to degree, multiplying it by 180 over pi, and we get 20 degrees, which means its complement is 70 degrees because they have to add up to be 90. Some of you stopped there and you lost a point. You lost half credit. Got to multiply this back by pi over 180.
These were worth 2 points?
So the tens will cancel. Nothing else will cancel. 7 pi over 18 is going to be your final answer. Okay? The other way, if you knew an angle was 20 degrees, how would we find its complement? Subtract it from 90, right. So if we kept things in radian form, what's 90 degrees in radian form? Yeah, so we could have just said pi over 2 is 90 degrees. From that, I want to subtract pi over 9. What's my common denominator? 18. What did I multiply the 2 by? 9, do the same thing to the top. That's 9 pi. What did I multiply the 9 by? 2, do the same thing to the top. And we get 7 pi over 18. And we just kept it right in radian form, and I didn't have to worry about anything, about changing it back. But again, your choice. But I think to your ability level, we should be able to start to think like that. For B, same thing. You'll see me do it 2 pi over 3. Again, I can change this to 180 over pi. Change it to degrees by multiplying by 180 over pi. And we wind up with 120 degrees. Oops, sorry. Way off the board. My supplement to all this, again, 2 pi over 3 multiplied by 180 over pi and cancel. My supplement to this would be taking 180, subtracting 120, and coming up with 60. But then I wanted you to write 60 in radian measure, which is pi over 3. That's the actual answer or final answer I wanted. If you start with radian, there's my measure. If I want to know its supplement, I would take that measure and I would subtract it from 180. So that's keeping everything in radian form. What's your common denominator? 3. Okay? So it was a 1. What I multiply it by to make it a 3? 3, do the same thing to the top. I get 3 pi. Minus, this stays the same, 2 pi. Subtract 1 pi over 3, and you get your answer right away without having to convert back and forth. Just again, open up your mind to that a little bit. Number 5, same thing this time. This time I use the word coterminal. Does anybody know what coterminal means?
Yeah, on the 4B one, you're looking for the supplement.
Right.
Okay, yeah. 180 minus 120
Is your pi over 3 or 60? Okay, coterminal. What does coterminal mean? Same terminal side, different angle measure. You know, when I showed you one, and we went through a couple, but you know, if I graph this, let's say, and this angle here is 110 degrees, and I want to know, give me another angle measure that would give me the same terminal side as 110.
470.
2 ways we can do it. We can stay here and go another 360, and we would be at 470. Good. There's a positive angle. That would be coterminal. What if we went this way? Just this way. We could take 360 and subtract 110 and get minus what? 250, I think?
Yeah.
Negative 250.
So, wait, you not be wrong for
Well, okay, show me after. But I wanted you guys to do this and also go, that was worth, well,
Wait, so 7 pi over 10 is 110.
I don't know if that's 110. I'm just showing coterminal. Okay? So, if I wanted to do this question, a couple ways we could do it. One is, I'll start with 7 pi over 10. And I'm looking for the side of the angle that's coterminal to that. So you could change it to degrees if you want to. Multiply this by 180 over pi. The pi's go, the 10 is going to go into 18, or 180 18 times. So I'm left with 18 times 7, 56, carry the 5, what's that, 126?
Yeah.
So 126 is the angle. So I can get 2 coterminal angles, one positive, one negative, by just doing that.
Oh, so you want these in radians too?
Yep.
So that's right up.
So when I add this, this is going to be 460 no, 486. And when I subtract these, I'm going to get a negative 234. Yes?
Yeah.
Okay. Now I'd have to take the time to convert all that back. All right, so I'd have to take 486 and convert it back by multiplying. That's probably not what I want to do. The easiest part here is to keep it in. The easier part would be to keep it in radian measure. So if you understand how to get coterminal angles, one positive, one negative, by adding 360, what's 360 in terms of radian measure? 2 pi. So I'm gonna go back to 7 pi over 10, and what I want to do is I'm going to add 2 pi to it. I'm going to go back to 7 pi over 10, and what I want to do is I want to subtract 2 pi from it. What's your common denominator? You know, common denominator is going to be 10. All right, 7 pi stays the same, plus, how can I write 2 pi so it has a denominator of 10? Or what did I multiply the denominator to make it 10? So it'll be 20 pi. 20 pi over 10 pi is 2 pi. But now you have it written so you can put these two together. If you put it together, you're going to get 27 pi over 10. There's your answer. Same thing on the bottom, except, see, once you do it once, it should be easier. 7 pi is going to stay, minus, this is another 20 pi. You subtract, negative 13 pi over 10. There's your coterminal angle as a radian equivalent. And I know when we went through this, we went through a couple where we were trying to keep it in radian. It was difficult to keep it in radian by changing these back to, especially without a calculator. So it would be easier just to leave it in terms of radian measure and go from there. All right?